Welcome to our video, where we explore the exciting world of artificial intelligence. From advancements in machine learning to the latest developments in natural language processing, we'll take a closer look at how AI is shaping our world. As you watch, remember to subscribe and like our video to support our efforts in bringing you the latest and greatest in AI research and development. Your support helps us continue to create cutting-edge content and make the most of the technology of the future. So sit back, relax, and enjoy the show. Robotic exploration of Mars has been a central part of NASA's mission to explore the Red Planet. Over the past few decades, NASA has sent a number of rovers and landers to Mars, including the famous Curiosity rover, which has been exploring the planet since 2012. These robots have made significant contributions to our understanding of Mars, but they have their limitations. One of the biggest limitations of current Mars rovers is their mobility. The wheels and tracks used by these robots can only take them so far. They are limited to relatively flat terrain and cannot easily traverse rocky or steep terrain. This is a significant problem, as much of the interesting science on Mars is likely to be found in areas that are difficult for current rovers to access. This is where walking robots come in. By designing robots that can walk on 2 or more legs, we can create robots that are much more versatile and capable of exploring a much wider range of terrain on Mars. However, building such robots is not easy. It requires a deep understanding of the mechanics of walking and the ability to train robots to walk in a way that is both efficient and stable. In recent years, there has been a lot of progress in the field of robotic locomotion. Researchers have developed a number of walking robots that are capable of navigating challenging terrain, such as rough and uneven surfaces, slopes, and obstacles. These robots use a variety of different mechanisms to walk, including biologically inspired designs that mimic the movement of animals. One of the most promising approaches to walking robots is inspired by the way animals walk. Researchers have found that the dynamics of walking are similar across a wide range of animals, from insects to humans. By studying the mechanics of animal walking, researchers can design robots that can walk with similar efficiency and stability. One of the key challenges in training walking robots is teaching them to balance. Walking is a highly dynamic process that requires constant adjustments to maintain stability. This is especially true on rough and uneven terrain, where the robot must constantly adapt to changes in the ground surface. To teach a walking robot to balance, researchers typically use a technique called reinforcement learning. This involves training the robot through trial and error, rewarding it when it makes progress towards its goal and punishing it when it fails. Over time, the robot learns to walk in a way that is both efficient and stable. Another important consideration when designing walking robots for Mars is their energy efficiency. Mars has a thin atmosphere and a weaker gravitational field than Earth, which means that robots must be designed to operate on much less power. Walking robots that are too energy-intensive will not be practical for use on Mars. To address this challenge, researchers are developing walking robots that are designed to be highly efficient. This includes using lightweight materials and designing the robot's gait to be as energy efficient as possible. By making the robot as efficient as possible, it can operate for longer periods of time on the limited power available on Mars. One of the most promising approaches to energy-efficient walking robots is inspired by the way birds walk. Birds are able to walk with a highly efficient gait that minimizes the amount of energy they use. By studying the mechanics of bird walking, researchers can design robots that are similarly efficient. Another important consideration when designing walking robots for Mars is their reliability. Mars is a harsh environment that can be very challenging for robots to operate in. Dust storms, extreme temperatures, and other environmental factors can cause significant wear and tear on a robot's components, potentially leading to failure. To ensure that walking robots are reliable, researchers are using a number of different approaches. This includes designing the robot to be highly durable, using redundant components to minimize the impact of failures, and using advanced sensors and control systems to monitor the robot's health and detect potential problems before they become serious. In addition to these challenges, designing walking robots for Mars also requires consideration of the unique properties of the Martian terrain. Mars is a rocky and uneven planet, with many steep slopes and ridges. This presents a significant challenge for walking robots, which must be able to maintain stability on such challenging terrain. To address this challenge, researchers are developing walking robots that are designed to be highly adaptive. This includes using advanced sensors and control systems to detect changes in the terrain and adjust the robot's gait accordingly. By making the robot highly adaptive, it can navigate a wide range of terrains with greater ease and efficiency. Another important consideration when designing walking robots for Mars is their ability to carry scientific instruments and other payloads. Mars is a fascinating planet with a wide range of potential scientific targets, from the search for signs of life to the study of Martian geology and climate. To make the most of these scientific opportunities, robots must be able to carry a range of different instruments and equipment. To address this challenge, researchers are developing walking robots that are designed to be highly versatile. This includes designing the robot to be modular, so that different instruments and equipment can be added or removed as needed. By making the robot highly versatile, it can be used for a wide range of scientific missions on Mars. In addition to these technical challenges, designing walking robots for Mars also requires consideration of the broader context of robotic exploration. This includes issues related to funding, policy, and public perception. While there is significant enthusiasm for robotic exploration of Mars, there are also many competing priorities for space exploration funding, and policy decisions can have a significant impact on the trajectory of robotic exploration. To address these challenges, researchers are working to build partnerships with a wide range of stakeholders, including government agencies, private companies, and academic institutions. They are also working to engage with the public to build support for robotic exploration of Mars and to demonstrate the potential benefits of such exploration. Despite the many challenges involved, there is significant excitement about the potential of walking robots to explore Mars. These robots have the potential to greatly expand our understanding of the planet and to make significant contributions to our scientific knowledge of the universe. With continued advances in robotics and artificial intelligence, it is likely that we will see increasingly sophisticated walking robots being developed for Mars and other planets in the future. Thank you for watching our video. We hope you enjoyed it. As a reminder, please don't forget to subscribe, like, and leave a comment on the video. Your support and engagement helps us continue to create high-quality content using artificial intelligence. We appreciate your interest in our work and look forward to connecting with you in the future. See you in the future.